Okay, so we're going to use the Cauchy-Riemann equations to prove a function is analytic nowhere. Just a quick reminder, analytic at a point is saying that two things. It says that f prime of z naught exists. That's differentiable at z naught. And secondly, f prime of z exists for all z nearby z naught. So that is, if z naught's here, you can find a small area around it such that the derivative exists everywhere there. So just a quick reminder of what analytic means. So what we're going to do here is, well, our function's already written in terms of a real and imaginary part. So we're just going to label them. And we're going to work out the first order partials of the real and imaginary part of f. So ux, which again is the partial derivative of u with respect to x, you'll find is 4x. uy, you'll find is 1. Vx, you'll find is negative 1. And Vy, you'll find is 2y. Great. So, we're then going to look at the solutions. Sorry, my dogs are running around. Solutions to the CR equations with these as our first order partials. So there's two of them, remember. Ux is Vy, and there's Uy is negative Vx. It appears that this second guy here is satisfied already everywhere. So that's fine. Let's pay attention now to this first equation here. So if we were to write this out, ux is 4x and vy is 2y. So we get y is 2x. So what this is telling us is that, well, the partial derivative for z, for our function f at z, could possibly exist at points where y is 2x. That is, on the line y is 2x. So let's draw a picture. So we learn that f prime of z could possibly exist along imaginary part is twice real part, and that's the line here. This, let's do an orange, indicate uncertainty. So there's our line. Now, so that's the only places where it can possibly exist. So in particular, f is not analytic away from it, because the derivative doesn't even exist. On that line, if we were to pick up a point, let's say here, the only time the derivative exists is if you possibly exists is if you're on that line. So you'll see that it's not possible to find a neighborhood around that point such that the derivative exists at all points in the neighborhood, because there's always going to be, most of the points in the neighborhood are not going to be on that line. So we can see that any point on this line, there does not exist a neighborhood such that f prime of z exists in that neighborhood. And so since the derivative just doesn't even exist off the line, and on the line the derivative can't exist in the neighborhood, what we deduce from this is that the function cannot be analytic anywhere. So there's no points. F is analytic nowhere. There's nowhere analytic. Let's write it like that. There's no points where f is analytic. So that's how one can use the Cauchy-Riemann equations to figure out where a function fails to be analytic.